Okay, it looks like we're recording. So thank you for those of you who are joining us today. I see that we have quite a few participants already. We just want to welcome Dr. Geoff Rowe, who's joining us today to talk about IMO and sulfur and how those are related to asphalt binder quality. Dr. Rowe is a pretty interesting gentleman who has tons of experience and probably one of the coolest minds I've ever had the opportunity to kind of interview or speak with. So I'm sure you're going to enjoy what he has to share today. I would like you to know, just wanted to put your attention to a couple things before Dr. Rowe begins. In the middle of your screen, likely at the bottom, you will see a image of people that says participants. If you do have a question, you can click participants and then you'll be able to raise your hand. When I see that, I'm happy to unmute your computer or your phone and you're able to speak and ask your question. We also have quite a few already questions that we have received that we have on the docket for Dr. Rowe to answer. So just don't hesitate, and please note that also when we're finished, we will have a report of who has joined us, and we are happy to provide continuing education certificates for those of you and can use those as well. So without any further ado, hand it over to Dr. Rowe.
Okay, well, thank you everyone for joining. And what I want to talk about is IMO and sulfur. And the first question anyone would have is, what is IMO and why are we interested with IMO and sulfur? So I'm going to begin this story by going through these slides, and let me just make sure I can advance them in the right way. There we go. IMO, what is this? IMO is the International Maritime Organization, and they legislate shipping rules around the world that all or most nations sign up to. And they are planning a reduction in the sulfur in fuel oil. This is bunker fuel that the ships will burn, and these limits will reduce to 0.5% in 2020, 1st of January 2020, which is only a month or so away. These limits have been slowly reducing from 4.5 to 3.5 and now finally 0.5. The big significance with the 0.5 is that this will be over the entire world, whereas if you look at that map on the bottom right-hand corner of the screen, previously the limits have been on coastal areas rather than a global area. So this is coming along very soon, and it's going to have a very large effect on the supply of marine fuels and how they are being supplied around the world. One of the things I've done with this presentation is I've tried to put as much as possible the links and the references on the slide. So you'll see on the bottom of this slide, there's a link to the source. And I've tried to do that on many of the slides so that you can go to the sources if you need to. If you look at sulfur standards around the world, they vary. The other map, which we show here on the top right-hand corner, shows the sulfur level in diesel fuel. So while sulfur level in marine fuel is changing, we also see sulfur levels in other types of fuel varying by region. Bunker fuel supply is shown on the second map there, and you can see the largest amount of bunker fuel is supplied out of Singapore, but there's many other ports around the world that are selling significant amounts of bunker fuel. And then the question becomes, why does that affect us? We're interested in asphalt, or bitumen as it's called in Europe and the rest of the world. And you say, well, how does that affect me as an asphalt technologist? Now, we see lots of headlines around the world over the past few years, and you'll see some folks saying bitumen asphalt consumers to benefit with the cost of bitumen reducing. Other folks will say sulfur fuel regulations poised to increase binder prices. So you have this dichotomy of almost conflicting statements in the press. Some folks are talking about refinery closures. You'll see the comment there about Shell, HES to resurrect the German oil refinery ahead of the IMO. So some people are opening up assets, some people are closing assets. And because of all of this going on, I decided to have a look at what's happening. And I really see this webinar and the presentations that I'm doing on IMO as more of a discussion on what do we know about sulfur and how does it impact us from the asphalt point of view. So if you first of all think about crude oil is generally classified by two major indices. One is its gravity and one is its sulfur content. So you see there's a couple of slides here or a couple of graphs that show the variation of sulfur content and gravity of the crude oil. Generally speaking, a high sulfur oil we consider as a sour product, and a low sulfur oil we consider as a sweet. This definition of sour and sweet came about because many years back, the refiners would take a sample of the wax and physically taste it. And the taste of a wax coming out of a sour crude would be sour, and sweet out of a sweet crude. If you look at this graph here, you'll see there's many crudes that are being supplied into the asphalt market. Crudes like Saudi Arabian crude, you've got West Texas Intermediate there. There's various other crudes there being supplied that go into asphalt production. The right-hand figure there shows the variation, the total crude universe that exists. And the blue bubbles are those that would be readily available to supply into the market with the IMO set at 0.5%. The crudes which have higher amounts of sulfur need some additional consideration. So those are the bubbles that folks are going to be looking at doing more complex refining of, or trying to put those crudes in other markets. High sulfur fuel oil is that material which is traditionally sold as a bunker fuel into shipping markets. It's provided a sales source for many of those higher sulfur products, and alternates are now needed. Shippers will need to buy either low sulfur products, or they'll need to fit scrubbers to their fleet. If you look at those photographs there, that basically shows a couple of photographs of elemental sulfur piles. One of those, the top one there, is in the port of Vancouver. That's actually being sold into a fertilizer market. The other pictures there are the pictures up in the Syncrude tar sands processing site in northern Alberta. So these are the two basic options that shippers have. First, to buy low sulfur fuel, or the second is to fit scrubbers to shipping fleets to remove the sulfur. Refineries have different options. They can either change the crude slate to a sweet crude for processing. They can do various conversion options, such as fluid catalytic cracking. There's a lot of different options that they can do with alternates in the to remove the sulfur from the oil stream. You can increase vacuum distillation cut points, so you take more material out. That's going to make a harder asphalt. You can make optimal use of non-residual refinery streams to make compliant fuel. You can sell the high sulfur residue back to other refineries, and there's certainly an arrangement being considered in Saudi Arabia for that. You can do alliances with ship owners, so you can actually persuade ship owners to take the high sulfur fuel oil with some incentives for them putting in the scrubbing facilities to remove the sulfur from the fuel oil while they're at sea. Or you can sell it into bitumen or asphalt. I use the word bitumen and asphalt interchangeably on this presentation, as bitumen is commonly used in Europe and the rest rest of the world. The graph there shows or the map there shows some interesting dynamics that are going on. If you look at some of the choices that refiners have, they can ship materials a long way. This graph shows material being shipped from Nigeria, Nigerian light, low sulfur crude oil going into the LA area ahead of the IMO regulations coming in. The suggestion that went along with this graph was that the refinery there is preparing fuel streams for IMO implementation in the new year. The second schematic there shows a hydro desulfurization unit, which is one of the refinery type choices for taking the sulfur out of crude oil. Some immediate thoughts. If you look at the US and the market in the US, we will see a differential between sweet and sour crude prices. This already occurs. The data shown in the graph compares Western Canadian select crude minus West Texas intermediate. And there's been some suggestions that as the need for sweeter, low sulfur crudes becomes more, that price differential will increase. So the potential there is that the price of sour crude might drop. And certainly there's been discussion that bitumen asphalt would increase and that the prices might reduce. Now I say might reduce there because if you look at the conflicting headlines, depending where you might be geographically, you might have some problems with supply. Other places might have adequate supply. Other materials will enter the market for bitumen production that previously had alternate uses. And one of the questions that folks are asking themselves today is, well, what about the chemistry? Will we see any changes in chemistry? The way we think of differences in the US is quite often we'll look at what's known as the PAD areas. They're the Petroleum Administration for Defense Districts. That's what PAD actually stands for. And generally speaking, if you ask me and you look at the pipeline routes on the previous map, you'll probably say that there's probably going to be less impact in PAD 2, PAD 4. There's probably going to be more impact in some of the coastal areas with the options that people will have for refining. But folks who are taking material from Canada in the central US, they're probably going to see a lesser impact of the IMO regulations. Some refinery practices that exist and some of the things that will come along are things like de-asphalting units, Rowe's process, and others. The de-asphalting units and Rowe's process make the use of solvent to take out the lighter oils from the asphalt stream. So it's a solvent de-asphalting process. And what you end up doing is while you're doing that, you are reducing the amount of sulfur in those products. These two processes here, I'm showing here, one is a solvent de-asphalting unit and the other one is a Rowe's unit. Both use solvent in the processes, and these are from the book developed by Spite in 2006, which is a good reference source for trying to look at this type of technology. This is an example of PDA. So this is the upper figure on that previous slide. And if you look at the yield of de-asphalted oil that one of these units might make, you'll see that as the yield changes, the amount of sulfur in that yield will change. So, if you want to remove some sulfur, this is one way that you can do it. And the PDA, the asphalt fraction that comes out of this, will then go into the bitumen market. This type of material has been around for a long while. I worked with this material in the 1980s. We used to call it propane precipitated asphalt back then. And we used the acronym PPA, which is now commonly used for polyphosphoric acid. But PPA or PDA asphalt was something that can be commonly seen in the literature in the 1970s and 1980s. So this certainly isn't new, but it behaves a little differently to conventional asphalt. Generally speaking, it's a little bit harder than the conventional asphalt that we traditionally use, but that's not always the case. So let's just go on and think about sulfur in bitumen, because at the end of the day, we're really concerned about what is the effect of sulfur in bitumen. I put this slide on because I wanted to go and talk about the fact that the discussion on the sulfur levels dates back basically just over 100 years. Richardson wrote this book, The Modern Asphalt Pavement, and this can be found online. Google have scanned this, so if you search on the modern asphalt pavement, you can download a copy. And he identifies sulfur as a chemical characteristic of interest. He talks about some of the early sulfur use, early use as a modifier to change asphalt properties. And in fact, he refers to refineries in Pennsylvania as implementing sulfur technologies in refining. He noted some ranges of 3.98 to 8.28 in pure bitumen. So this is going back a number of years now. Then we can go on to the work done in Chicago. In 1950, a gentleman by the name of Victor Nicholson specified 3% sulfur. And the reason for this was to address what he called apparent shortcomings in these specifications. This can be found in a paper in the Association of Asphalt Paving Technologists in one of their journals in 1935. This move by Nicholson in Chicago was somewhat controversial. And if you look at the time period between 1935, when he presented his paper, and 1940, there was a large amount of work done by two gentlemen, Lewis and Wellborn. They were with the Public Works Administration, which is, if I'm correct in my understanding, the forerunner for what we now consider as the FHWA. They wrote an extensive analysis of various chemical components in asphalt binder in 1940, and really suggested that the sulfur content as a specification parameter was not the best way of thinking about trying to control sulfur. And they showed that many binders that had lower sulfur contents had adequate performance, and really the limits that were imposed in Chicago shouldn't be imposed on a nationwide basis. And there's some considerable discussion in that paper also by Nicholson at that time. So that's a bit of history. So what about where we are today in sulfur contents in materials? Nicholson quoted, or Richardson quoted, that range 3.9 to 8.3. This table is taken from Spite's book again and shows a range of vacuum distillation unit output, and the range goes from 0.2 to 5.5. The reason I put vacuum tower output here is this is our old style bitumen. If you think of the material coming out of a vacuum tower, we would traditionally have considered that as a straight run binder or asphalt material ready for use. I mean, obviously, depending to a certain extent on the cut point that's used, the higher the temperature of a cut point, you'll make a harder product. So folks would vary the cut point temperatures to try to give them something that they could use. Now, going on a few years, we can go to the SHARP binders. SHARP was the Strategic Highway Research Program, and this was the study that led to the development of the Superpave binder specifications. One of the things that they did is they wanted to select binders that would represent those in traditional use in the asphalt industry, and they presented various chemical analysis, various empirical properties, and you can see the sulfur contents here for the sharp materials vary between 1.2 to 8.3. That's the high level here is just about the same level as Richardson's 8.28. So really what this says is from 1907 to the time that this work was done, the overall sulfur levels in bitumens, the maximum levels tended to be about the same value. So this is what was done there. Now, what we can do with that data is we can look at some of the properties, the physical properties that that's associated with the sulfur. We know that the higher sulfur contents are generally associated with higher asphaltenes, and typically those binders have more structure and lower temperature susceptibility. I'll put two graphs here. One shows the asphaltene content compared to the sulfur, and the second one shows the penetration index versus the sulfur. I've put the R squared on each of them. The relationship with penetration index isn't so good, and the outliers tend to make that line lie over a bit. You might say, well, maybe it should be more than 45 degrees there on that graph. But certainly we see that the higher sulfur binders tend to have more structure. The relationships aren't that great. Maybe if we did testing with today's equipment, we might actually yield better trends and better results. So going on now to Superpave and PG grade binders, how do those compare? Well, what we did with we've done an analysis of this data, looking at the PG range versus sulfur content and the actual low temperature and high temperature grade as specification boxes versus the sulfur content. So I should just take a minute and explain where this data came from. The percentage sulfur that you see in these two charts came from the original sharp work done in the early 1990s. The PG testing in these two charts came from a reanalysis of the sharp core asphalt binders, which was done by the Asphalt Institute around about 2014, 2015, and this data was reported to the binder expert task group. The sharp core asphalts are those asphalts that all the sharp researchers at the time, so I'm talking about folks in the late 1980s, early 1990s, had to include in their work. And I was one of those sharp researchers going back to that time period. So if you look here at the PG range versus the percent sulfur, you see there's a fairly strong correlation. Those binders with a higher PG range generally have the higher sulfur contents. And then if you look at the specification boxes that we have, using this arrangement where we plot low temperature PG grade against high temperature PG grade, we see that we have binders like AAD, AAK as good performing products. AAD is the California coastal binder, AAK is the Boston binder. Those both have just over 6% sulfur. If you look at binders which are more temperature susceptible, have lower performance, we would look at binders like AAG, California Valley, AAC, and so on. So this graph is a useful way of looking at what a particular product from a crude source will do. This concept was originally developed by Olga Putzik of Imperial Oil in Canada, around about 2006. Okay, so we'll go on from this and we'll look at some comments made by some of the sharp researchers. So this slide basically contains the perception at the time of sharp, and this perception, should be commented as being sometime around about 1987, 1993 time period. They particularly note the oxidation of sulfides to sulfoxides would be expected to increase the asphalt hardness and viscosity. And certainly we see as sulfoxides do oxidize as sulfides oxidize to sulfoxides, then you see increased hardness. But we should probably track not just sulfoxides, but also carbonyls. So what we not normally do now is we track the combination of sulfoxides and carbonyls. The couple of comments about the AAD, the Californian Coastal Binder, and the AAK binder in this report. Those binders were perceived to perform poorly with respect to one or more types of pavement distress. And they made a comment that a negative correlation of performance with oxidizable sulfur content is indicated. But on the other hand, you should note that these two binders actually are fairly well-performing binders in the Superpave system. So there's some dichotomy in these results that we read in these older reports. These are the binders that we see here, the Californian Coastal and the Boston binders. You can see the sulfur contents there, 6.9, 8.3, 6.4 and 6.9, respectively, for those two binder types. Other comments in the Sharp reports reference sulfur, nitrogen, and metal contents, are all part of the bitumen selection process. So one of the things that they did do in the Sharp studies was to look at the chemical constituents of the material and try to select those that would cover a range. For the high sulfur asphalts, AAD and AAK, they looked at these amphoteric fractions to account for most of the viscosity, whereas the AAG and AAM, the low sulfur asphalts, they saw the viscosity falling off, and that's a comment in the Sharp report A686. AAG is a sol type asphalt, whereas AAD and AAK have significant structure. And this comment is based on the old sol gel classification of binders. AAM, they commented, was unusual. Again, it's a little bit different in its behavior. They also noted low aging indices with binders having low asphaltene to resin ratios and low sulfur contents. And then there's a reference there to the Sharp report A686. And the implication is that higher sulfur asphalts age to some greater extent. But one of the things that we must consider is that many of these higher sulfur asphalts have other things that may affect the aging, such as metals and other aspects in them. So we have to be a bit careful how we take this work from the late 1980s and early 1990s and apply it today. What about added sulfur? Sulfur has been added to bitumen as a modifier, or asphalt as a modifier, and it's been added for many years. It's been looked at as a warm mix additive, been looked at to improve stability, stiffness, rut resistance. With fatigue cracking and water sensitivity, there's been some mixed results, but there's been a large volume of work to consider adding sulfur as a form of product. There's still some concerns about the safety and the generation of hydrogen sulfide class. Some of these graphics on the side here show the recent use of Superpave, which was a product implemented by Shell, and there's a reference there to a TRL report, which was done out of the United Kingdom in 2009. But then you can look at sulfur going back in asphalt research reports nearly 100 years. Richardson discusses it in his 1907 book as a modifier for producing different types of asphalt in a refinery process as a catalytic type material. But certainly it's been added as an additive to an asphalt binder for a long period of time. So I would say there's really 100 years plus of discussion about sulfur. And really this starts in 1907 in the most significant way in Clifford Richardson's book, and goes through to papers that are still being published today. So really we should go out and try to make sure that we do include the full amount of literature in what we're trying to investigate. Possible trends and the way the industry, the way we might see the industry going. Things that might occur, we'll see the use of higher asphaltene contents in sour crude selection for bitumen manufacture. I'm certain we will see more shipping of these products. If you recall the slide that I showed earlier with Nigerian light crude being shipped to the Los Angeles area, we will also see heavy crudes and sour crudes most likely being shipped into the more complex US refineries. The refineries in the US tend to be more sophisticated than in many places in the world, and we can actually cope with different types of refinery options much better. With regard to the performance of the higher sulfur content sour crudes, they're going to tend to produce a bitumen with more structure and different chemical compositions. Will we see different aging as suggested by the Sharp reports? It's a possibility. This is one thing that the bitumen manufacturers and the bitumen users will have to be aware of. And I'm certain the bitumen manufacturers, in their crude selections and purchasing and trying to implement these different crude sources, will be very carefully studying the aging process. Will bitumen asphalt as a supply, will we see folks just adding sulfur to it? Will folks just throw elemental sulfur in it? This has been a question posed to me. Will we see indiscriminate use of bitumen as the dumping ground? I think not. I think the answer to that question is basically no, mainly because this will not be consistent with solubility. It poses some extreme risks to health with the generation of hydrogen sulfide and gases. And the other thing that we should remember is that the sulfur bound up within asphalt binder and bitumen in the way it's supplied by nature and the way it comes out of a refinery, out of a vacuum tap, is very different to an elemental sulfur being added. We will need to ensure that the rheology is compatible with existing materials. We'll need to look at the normal sort of analysis that we do, the tighter components like SARA analysis. SARA is the analysis where you split the asphalt binder into fractions, which are saturates, aromatics, resins, and asphaltenes. So you split it into those fractions. So you look at how well you can modify it. And typically most people looking at modification will be looking at some sort of SARA fraction. And then, we'll need to tie the performance to parameters such as the rheological index developed by Christensen and Anderson, the Glover-Rowe parameter, the crossover modulus, the viscoelastic transition temperature, etc. There's a whole host of new parameters that are being looked at for durability. And my suggestion to refiners and people concerned about durability aspects is to evaluate their materials to these. Delta TC is another one that I would throw in there as well. Of key concern is cracking and durability of mixtures containing binders with possibly different chemistries. To fully understand these, we need to carefully evaluate the stiffness properties in the range of the modulus of 1e to the 5, 1e to the 9 pascals, since that range of stiffnesses covers the cracking, raveling, and durability parameters. So this is a very straightforward testing, something that can be done with a combination of BBR and or DSR type testing. It's been suggested that heavy components in some sour crudes may not be suitable for asphalt or bitumen production. Maybe we'll see some of those entering the market. This is what we have to guard against, and this is what we need to work with the refiners to make sure that they understand the need to very carefully assess the materials so that we don't have materials entering the market that shouldn't be entering the market. So if you ask me my perspective on the changes, maybe we'll see some pressure to reduce the price of asphalt binder relative to other materials produced. With shipping market developments, I, at the moment, would suspect that this effect is going to be smaller than originally anticipated by some of the discussants in the industry. If you look at the Argus websites and the other websites, you'll see some folks are almost excited that we're going to be able to pave more roads as the prices reduce. But I think it's going to be fairly marginal. Some materials may be processed into other products in some markets, and thus an asphalt bitumen supply may no longer be available. We may see some refiners say, well, we'll just turn it all into coke, or we'll do something different with the refinery economics. USA regions supplied from Canada, I think we'll see little change in the asphalt bitumen properties. Larger changes will occur in some other markets. Some additional heavy crudes are almost certainly going to be imported into the complex US refineries. And I think, refineries will be looking for opportunities to buy materials at discounted prices. So, it can really be a more, something that they can give them an advantage in the market. Supply of asphalt binder will see more crude sources. Most likely we'll have more structure in the asphalt binder, but we do need to understand the effects of aging. Polymer modified binder producers will be carefully considering how the change in sulfur contents is affecting their materials. Cross-linking and sulfur scavengers may become more popular. Heavy products have traditionally been considered more difficult to modify. So if we end up using asphalt binders that have a heavier fraction in them, higher asphaltene contents, that may cause some issues for some folks with modification. We need to be aware of the changes in the heavy fractions. How the asphaltenes behave is very important, and certainly the work being done by Western Research Institute and Jean-Pascal Planche and his team to understand the asphaltene importance is critical to the way we move forward. We need to be careful with propane deasphalted materials, PPA as it used to be called. Generally, those materials are harder and generally they have a lower useful temperature index. But that's a generalization and certainly isn't always the case. So just to summarize, before we take some questions, IMO is going to be implemented on January the 1st, 2020. Many of the changes that are going into that implementation have already occurred. This isn't something that happens on one day and it gets implemented with the swipe of a guillotine. Oil refiners, bitumen producers have been implementing changes certainly for the last 5 years as they prepare for this. It will and it has produced a significant change in refinery processes and materials available for bitumen production. So you note that I'm talking partly in the past tense because this is already going on. We need to understand if we will see change that will have a consequence in the asphalt market. So we need to very carefully understand what's going on with bitumens, what's going on with our asphalt materials to understand how the changes are occurring. The historical documents, the documents I've reviewed suggest that the changes will occur in cost structures and performance. This is something that we think is almost a certain aspect. I put here as my final picture or graphic a crystal ball, because one of the things with the oil supply market and the complexity of all the dynamics involved is we're still guessing. And my final comment there is, has anyone got a good crystal ball? And that's where I'll leave it for now. I think we have some time for questions, and I'll be happy to answer any questions.
So if you do have questions, again, you can click the participants button that you'll see in the bottom of your screen, and you should be able to raise your hand. Happy to take any of the questions we have right now. I've always also had some written in previously. So we'll go ahead and start with those. And if you do have any additional ones, we'll be monitoring those and be sure to get to those. So with regards to implementation, Dr. Rowe, is with regards to, we understand that this has been being implemented already and is been a kind of a subsequent process, but what are some of the penalties or the enforcement that is happening in order to help with implementation and participation?
Well, the implementation of IMO depends upon the various governments controlling and implementing the shipping rules around the world. The refineries have started implementing this in terms of their productions for quite a while. So I think we're in that process.
There?
Yeah, are you hearing me?
Oh, yes, yes, yes. Okay, just wanted to be sure. So what would you say for anything additional with regards to sulfur storage across the world and how that's going to be changing as forward?
Yeah, sulfur storage has been something that's, you see those mountains of sulfur in various places around the world. And I think we will keep seeing sulfur mountains growing until somebody else finds a good use for them. There's an excess in the sulfur supply at the moment in the world.
All right. I'm not sure if you hit on this earlier, so if you did, apologize. We're going to ask it anyway. So the market, talk about areas that are going to be more hard hit or where we should be paying attention.
Yeah, I wouldn't like to use the word hard hit. I would say the places we're likely to see more changes are those areas where shippers can move material more readily, which would be more of your coastal refinery areas and those areas. Where you have simple refineries in the world versus complex refineries, those refineries are going to have to make strategic decisions if they want to be in the bunker fuel market. So, I was in South Africa just a few weeks ago, and you look at the refineries around South Africa, they're all fairly simple in their structures. So those refineries, have some challenges if they want to carry on producing asphalt. They're going to have to consider how that's done, maybe, run special runs for making asphalt, or maybe some of them will decide that that's not something they want to do, and then they'll concentrate on other markets. So the market is very dynamic. There's lots of consideration going on that, as civil engineers and road builders and asphalt users, we don't see that information. And this is something that's occurring around the world, and we see it via the comments in the press.
So the last few questions we have were related to kind of perhaps the pricing and kind of quantity availability. And I know you mentioned earlier that kind of price change would be marginal. And then also the question was with regards to how it'll just affect the quality. And you did speak to, the aging of polymer modified asphalt as well. So those were the only two additional questions that we had written in or asked previously. I don't know if I see any more online. So if you are on the call and you have a question, please feel free to raise your hand. I'm happy to get to those. If you have questions as well that you are not able to because you're mobile right now and traveling and can't ask, we will be providing contact information for. If you have any follow-up questions, we're happy to facilitate you getting those answers. So just give just a second more to see if we have anybody else with questions that's able to ask. Again, before we sign off, I just want to thank you to our presenter, to Dr. Rowe, for taking the time to share with us. He's overseas while he's talking to most of us, I believe, who are based in the United States. And to all of those of you who have participated, like I had mentioned at the beginning, we will be sharing with you a certificate of so that you can hopefully find those useful for your continuing education requirements. If you have not signed up to receive notifications for these webinars, please go to connectingthegovdots.com to sign up. We welcome your feedback and any additional ideas you have for future webinars. These are all based on what you find most useful, so we highly value your feedback. So again, thank you all so much, and we look forward to hosting you again soon.